field pattern around a bar magnet. Field pattern around a bar magnet. Field pattern around a bar magnet. Okay, so if we have a bar magnet, this one is a bar magnet, and in bar magnet we say it is having two poles. There is magnetic field lines, which we have discussed, and we have given the characteristics of those magnetic field lines. So then there is magnetic field lines running from north to south. Magnetic field line which is running from north pole to south pole. Running from north pole to south pole. So this one is the magnetic field lines which is running from north pole to south pole, and we must show it the direction by using an arrow, which is originating from north and end at the south pole. Okay, so then we will find that we have some of the magnetic field lines like this. We have some of the magnetic field lines which is towards the south and away from the north. This one now, when you check this, there is a pattern which is formed here. In this line, it is forming a certain pattern. That's why we call it the magnetic field pattern. So this one now is the magnetic field pattern around a bar magnet. Okay, field patterns now around unlike poles. Field pattern around unlike poles. Field patterns around unlike poles. For example, if we have two bar magnets, and we have here north, this one is south, this one is south, and this one is north. The two are unlike poles. When you bring the two poles, which is unlike, closer together, then in the basic law of magnetism, we say it will attract each other. So then we will find the magnetic field lines now running from north like this to south. These are the magnetic field lines running from north to south. So this one now is we have the magnetic field lines which is running from north to south. This one is the field pattern around unlike poles. Field patterns also around like poles. What will now if we have the like poles? Field pattern around like poles. Field patterns around like poles. And when we talk about the like poles, it means it can either be south pole and south pole, or north pole and north pole. So if we have this one now, if we have the bar magnet and we have the other bar magnet here, let's say this one is north, this one is north, this one will be south and the other one will be south. So which means the two poles are like poles. What did we say in the basic law of magnetism? We say that like poles will repel, but unlike poles will attract. So because this one now is the like poles, then there will be a repulsion. So then it will be repelling each other like this. So then you will find the magnetic field lines repelling each other. So then there will be a repulsion. And you know this one, because this is not a north, then the magnetic field lines is originating from north. That's why now the arrows is coming from the north pole. What if we have the south pole and south pole at the same point? So then let's say we have this one to be south pole and also this one to be south pole. Let's say we have the south pole like that. There will be also a repulsion. You will find also they will be repelling each other. Why? Because they are like poles. But you should check the arrows now here. This one is south, this one is south. So it is now coming toward the south, because it is coming from where? From the north pole. So the arrows now, you should show the arrows which is moving toward the south. moving towards the south. So then you check these arrows, in the south, in the south. So it is toward the south pole. This one is away from the north pole. So this one now is the field patterns around like poles. What of if we have a horseshoe magnet? If we have a horseshoe magnet, what is the magnetic field lines around a horseshoe magnet? This one is a horseshoe magnet. We have a horseshoe magnet like this. This one is a horseshoe magnet. This one is a horseshoe magnet. So this one is a horseshoe magnet. And it's a horseshoe magnet also, it is having two poles. It is having also north pole and south pole. Okay, so then, because this one is north and this one is south, so then always, the magnetic field lines always originate from north pole and end at the south pole. So this is the magnetic field lines which is running. It is running from the north pole to the south pole. This is how the magnetic field pattern is. So this is now is what we have. It is towards the south. This is the magnetic field lines around the horseshoe magnet. So this now is what we have about that one. Okay, here now, this point now, because they are repelling each other, in between there will be no field. So here now, this one is X and this one is X. So which means it will be cancelling each other. This field and this field, because they are repelling, then it will cancel each other. So this point now, we call it a neutral point. That means there is no magnetic field there. So this point X is a neutral point. This is a neutral point. And even here, this one also is the same, which is the neutral point. Neutral point. Okay, so then next is the effect now of soft iron rod and ring. Effect of soft iron rod and ring. So then we will see now the effect. So this one is what we have. Effect of soft iron rod. Effect of soft iron rod and ring. Effect of soft iron rod and ring. Effect of soft iron rod and ring. For example, if we have a bar magnet, and this one north pole and this one is south pole, and we have a soft iron rod here. This one is soft iron rod. First of all, what do you know about the soft iron rod? Soft iron rod is a magnetic material, so which means it will be attracted by the magnet. So then, this north pole will attract the soft iron rod. So which means all the magnetic field line will be directed towards the soft iron. So this is the magnetic field lines now here in the soft iron rod. This one is how the magnetic field line is concentrated towards the soft iron. So then some of the magnetic field will emerge at the end of that soft iron rod. So this one now is how it will happen in the soft iron rod, and we have a bar magnet here. And remember, this one is a magnetic material. Okay, so what if we have the soft iron or iron ring now? So if we have the bar magnet here also, this one to the north pole and this one is south pole. And in between we have the ring. And the other side we have also a permanent magnet which is in the south. This one is north. Here there will be attraction here, and then those magnetic field lines will be also directed towards the south of the other magnet, because we say unlike poles attract. This one is the magnetic field pattern now which we have. So then it will be running like this. It will be running from north to south. It will be running from north to south. This one is what we have. The magnetic field lines is running from north to south. And we show the direction. This one is running originating from north and also toward the south. Okay, so this one now is the soft iron ring. Soft iron, soft iron ring. That one is what we have in the soft iron ring. And you should know that a ring, inside the ring, it is just a space, there is no material. That's why now we have this space here. And this space here, we can take it to P3. What do you know about that space? There is no magnetic field here. And then we say that point P is shielded. This point is shielded here. So then it is shielded, which means there is no magnetic field at that point. So this now is what we have in the soft iron rod and the soft iron ring. Soft iron rod and the soft iron ring. That one, which is the earth magnetic field. The earth